Yeah, g'day YouTubers, Tinker O'Toole again with another video. Today we're going to talk about how to set up a lathe. In the case this is a Hercus 9A lathe. And we're going to talk about external threads. Internal threads are a little bit more difficult because it's like a boring bar with a tip on it, but you can't really see what you're doing because it's hidden because it's going into something internal. So you need a little bit more experience in boring before you tackle internal threads going into a hole. All things can go wrong. You can smash everything up. But you can smash everything up on the outside tap-in threads as well. So we're going to go over how to set it all up and avoid smashing everything up. And you want to be using slow speed until you've got a lot of experience. Now the other thing is to tap threads, you need a 60-degree angle on the cutting tip, and I'm using tungsten carbide tips. I don't use high-speed steel. You've got to grind them, so I'm using these Hercus threading inserts, and you can see that the little point. Just see whether we can zoom. We can see that. You get 3 goes out of this, so you got that 60-degree point. There it is there, 60 degrees. Now, the other thing is, when you actually set up the lathe, the cross feed, you need to set the compound angle, the angle on here, at 29 and 0.5 degrees. Because what happens, the point of that 60-degree carbide bit goes into the steel and cuts this side. So it's angled at 29 degrees, so it's always cutting in that direction. You can cut them straight, but it's actually get a slightly better job on this angle here. So just remember, you've got to set that up 29.5. That's what's recommended. And the reason, it gives it a little bit of clearance, I guess, because the carbide tip is 30 degrees per side, so that's a 60-degree included angle, and it just works better setting this at 29.5. You could possibly put it at 30 and not notice a difference, but yeah, it's recommended by most people that you set that at 29.5. The next thing that you have to set up, especially if you've got an old lathe like this, it came out with imperial gears, and it's got an imperial chart on it. And the imperial chart is here. We'll just zoom in on that. So this was the chart for the imperial threads. And you got your tumblers, right? So this is your left tumbler. You got A, B, C, and D, and E. You got A, B, C, D, and E. And if we sort of go down and correspond, that is A, that is B, that is C. You got A, B, C, D, and E. And you can see how that corresponds to the chart, because A is up the top, B is down the bottom, C is up the top, D is down the bottom, and E is up the top. And then, if you look at this gear lever here, it's set on number 4, because we've got the lathe set up to do a 2mm pitch. And this is for imperial, not for metric. So you've got to make sure that the lathe has been converted to metric, and it has. And I can show you the gears, and then we can look at the little, there's a little plate that came with the gears, or you purchase it separate, I don't know, it's going back a long time. And it's got the information that you read off here. So you've got to translate from one brass plate and translate to this and set up the actual gear levers, the tumblers they call them also. Now, any lathe that you use, some will be more advanced than the others. Anything that's fairly old will have a gear set like this. Now, when it was converted using this compound gear. You've got 127 teeth on the outside, right? And you've got 100 teeth on the inside. And then for the spur gear, we've got 40 teeth on here. And this one runs the screw, the threading square cut screw on the shaft. It's on the gearbox. And that's on 56 teeth. So you have to look at the chart, and what you'll change will be this gear here. This gear stays. This is the metric gear set. There's also another set that's 63 teeth. So there's more than one option for metric, but this option here comes with this compounded gear. And you can buy that. You still buy them today. There's a guy, I think over in South Australia, that's got a website, AH something, or I can't remember the exact name of it. But it's in one of the Hercus forums. You can sort of do Hercus. There's a Facebook group, and you can sort of find that information out there. And he sells all these gear sets. So apart from this compound gear set, there's also a whole bunch of other gears, and we've got them up there on the wall, right? So when you go to a different pitch, like an example, let's say you're going to do a 10 mil thread, and you need to probably change this spur gear, and you'll need to change the tumble levers or gear levers on the gearbox here to get the right pitch. So that's the first thing that you've got to get your head around. You've got to get the right gear set. If you've got the right gear set, it should have came with a plate. So for the gear set that I've got, this is the plate that it came with. And what we will do is just put a picture up on the screen. For those that may not have the nameplate, if you look at the picture, you can take a snapshot of it. But if you look at the first column on the left-hand side, you'll notice it's got millimetres and it's got pitch. And it goes from 6 millimetres, which is, yeah, that's huge, right down the bottom 0.4. So they're all your different pitches. I've got mine set up on about 2 millimetres. That's about halfway down. So if you scroll halfway down, you'll see that. Now, corresponding, you'll see a gear lever positions. And that's what we spoke about before, about the gear lever on the gearbox. So if we actually have a look at that now, there's the gear lever, and it's saying position 20. So what you need to do, and we'll have actually zoom in there and have a look. Gear lever position 20, which is here. If you go across and you actually have a look at left-hand tumbler, that's what's written up the top there, left-hand tumbler, says it needs to be on B. And if you actually have a look, there's B down the bottom, right? You can find that there, A, B, so that's B. And then you need to look at what column that the 20 also responds in, which is column 4. So you've got 1, 2, 3, 4, there it is there, 5, 6, 7, 8. So there's 8 columns, so we need to be in column 4. That means that we set the tumbler, 1, 2, 3, and it's in number 4. That's the correct setup for metric 2 millimetre pitch. So it's all set up. Okay, we'll just put that picture back up. Now the next thing you need to do is look at the stud gear. The stud gear was the gear that I showed you before, which was a 40 tooth. And if we just come around to the side, we'll just show that again for those that are not too familiar with the stud gear. That's the stud gear there. All right. So you need to have that in there as well. Okay, back to looking at the chart again. The next thing you'll see, and you'll see it from the top to the bottom, right, over on the 1, 2, 3, on the fourth column, you'll see 127, goes all the way down from the top to the bottom, it's got 127, and you go over the fifth column, you'll see 100. What that is that's the 127 tooth here, and that's the 100. That's the compound metric gear set. And if you go over to the last column, you'll see where it says 56 here. So that's the gear set that you need, right? All we've done is put a little bit of a groove in there, because when we're turning, and you'll see this tip here, right? The point. As it starts to cut into the metal, when it gets to the end, you've got to turn the lathe off manual, because I can't disengage the half nuts, the gearbox, the shaft. Everything's all connected. And I'll show you the procedure that we do next. So the next procedure that we're going to do is that we have to engage what we call the half nuts. And this is the feed in. So our feed screw, we need to engage that. So when we turn the lathe on, right, that's engaged. Now, it runs a little bit fast, even in slow speed. And this is what you've got to be careful of, that if you don't use that back screw, right, the back gear, I should say, if you don't use the back gear and you go too fast on a 2mm thread, it's going to travel that fast that you're liable to end up running into the jaw. And that's why I've got slow speed. So now it's just a matter of, I can't move the carriage. The carriage is locked in. So what we need to do is to start the lathe, bring the cutting tool in so that it just barely touches, and then the moment that the cutting tip reaches that groove, you have to turn the lathe off, and you have to make sure that you don't turn it off when it's sort of getting to this side of the groove, because you can end up smashing the tip, and I've done that before. So now we can turn the lathe on. It's automatically feeding, and I haven't gone in far enough, so I need to just turn this in. Okay, now I'm touching. What I need to do for reference purposes is that I need to set this on 0 now, right? So we're touching to know where I am. So I'm going to set this at 0. So it's in tens of thousandths of an inch. And you've got the graduations in between the 10. You've got 10, 20. So, yeah, they're the 1,000. So we'll back that off, right? Now what I need to do is put the lathe in reverse, right? So I need to put that in reverse. And what's going to happen when we turn it on, it's going to reverse back out. Okay. The next thing you need to do now, we had this on 0, I'm going to take a 10th thou cut. So we put that on 10th thou, but it will actually take 20th thou because it's 10th thou aside. Now, turn the machine on forwards, start your lathe. It's doing a spiral cut now, and you need to stop that right at the very end. There it is there, perfect. we'll do that again. It's actually cut the spiral. There it is there. So that's the first pass. Now, this can get very tricky, and if it's not done properly, you can damage things quite easily. So that was 10 thou. What I'm going to do is just wind that back to 0, and I'm going to put that in reverse. You have to make sure that you wind it out past 0. Otherwise, when it's in reverse, you don't want to be using the cutting bit in reverse because it will make damage. Now, we were on 10. So that's cleared. We'll put it back in the forwards. We need to look down on here, and we need to go to 20 now. Okay, so now we're on 20. And what we're going to do now, we'll zoom in there so you can really see this. We're going to turn the lathe on, and it's going to start cutting a little bit deeper. And we need to do this probably about 7 or 8 times until we get the thread spot on. Hopefully you can see this quite good. A little bit more cutting oil. Okay, so there's the spot. It's cut slightly deeper again. Now you've stopped. You're going to have to wind that back out past the 0. So I'm going to wind that back out, right, so that the cutting tip clears the thread. You need to put that back in the 0. Turn the lathe back on. You see that it's time consuming. Okay, put that back in the forward position. Now we had that on 20, we're going to go to 30, right? Could possibly go 35, I'll go 35. So now put a little bit more cutting oil on that. We'll start that again. See, that's taken that off a little bit deeper. Got my hand on the switch. Now I need to back that off. Put that in reverse. I actually went a little bit further past on my shoulder, so that was a bit of a mistake. I couldn't see good. I've got the camera in the way, so yeah, sorry about that. Okay, now that was on 35, so we're going to go 45, put her back in the forwards, and we're going to start again, a little bit more cutting oil. Don't need a huge amount of cutting oil, but we need enough. Back that off again, put it in reverse. What I like to do is back that off as I turn, just almost simultaneously as I turn the power off. Okay, back in the forwards position. We'll put this on 50 thou, and that means that we're going to cut even a little bit deeper again. Okay, at any pass, I'm just going to get the thread gauges out. We just need to go a little bit deeper on that. So now we're ready to put it back in a reverse. Send it back in the other direction. Wind this back in again. We'll take it up to about 60. Okay, put it back in the forwards. This may be getting close to the final part. Okay, let's just check that. Look, that's pretty bloody good. I'd say that's good enough. Nothing wrong with that. That's actually quite good. Now I've just cleaned that up with a file, so it's just a matter of sometimes what you need to do is put that on there. There's only a little file, usually use one much bigger. Just be careful with your fingers, getting close to the chuck. And then I'll just use a wire brush, brass brush actually. Clean that up a little bit. Look, it depends on, the faster you go, you'll get actually a smoother finish. So the slower you go, yeah, it's a little bit rough. A little bit, but nonetheless, it's still okay. And this one here will now fit in. You can see the pitch is perfect. It fits in really good. So that thread will get it out. That's turned and it'll be ready to use on anything that you want. And we take that back out. And if we have a look, hopefully you can see those threads. See how they're not really sharp at the top when they come to the point? It's the last thing that you want. We'll get the thread gauge, you'll be able to look at that. There they are. Turn it around the other way. Might be able to see it a little bit better. Could have possibly went a fraction more. That's not too bad, but. Now the other thing is, it could have possibly went slightly more. But I didn't have a nut that size, so I couldn't test. Can you see on the top there where I was saying before about don't come to a point? Because if you come to a point, it means that you make sure that you don't go too deep into the thread. Because if you come to a point, that's the weakest part of the thread. So you need to avoid coming to that sharp point. And there's no point going deeper into the bar stock just to make it deeper when it's not going to, there's no advantage going too deep. And if you don't go enough, then you'll find out that the nut will be too tight. That's why it's good to have a nut and check. So you need the thread gauges and you need a nut that will fit whatever you're turning to check. And as I said, that metal that I was turning is actually mild steel. Got to be the worst metal to turn. Doesn't leave a smooth finish by any stretch of the imagination. So, yeah, it depends on what metal that you use. Mild steel has its benefits, but it's also, yeah, the worst metal to turn. A lot of the tool steel leaves a much better finish because it's a lot of it has different. Well, it's got a bit of lead. A lot of the good steels have a tiny little bit of lead in them. That makes it easier to turn. Look, I hope that information helps. It's gone for a while about turning threads. You need to practice on something. Only what I would say, and I couldn't really get in, the camera's right in front of the controls of the lathe. That made it extremely difficult for me to operate it efficiently. But when you've got a shoulder like that, you've got to get on the off and on switch, and you've got to precisely turn that lathe off and at the same time wind that out like that to clear. Because if you don't, I've snapped off many carbide tips when doing a shoulder. All right? So yeah, just remember that when you're doing shoulder. So carbide tips are very brittle, and if you overrun or you take too much of a deeper cut and you just don't do it properly, you can quite easily snap off the little tiny tip on the end of the carbide bit. High-speed steel, even if you snap off the little tiny bit, you can always resharpen it on a grinder. But whereas a carbide bit, you can't resharpen it. You've got to throw it in the rubbish. So just be careful with the carbide bits. They're not the cheapest bits out there. They're roughly about $9 for a bit. You get 3 corners on the triangle. And as I say, if you don't watch what you're doing and you smash them up, it's going to cost you money to keep replacing them. But it's like everything else. Practice makes perfect. And if you're a little bit... look, if you're a little bit not watching what you're doing, I'll guarantee that you'll start snapping tips. So then you need to focus, and you've got to get your timing correct, that you withdraw that. By the time you get to the end of where you're turning your thread, rotate this backwards and make sure that you know where you started from. So make sure you set this to 0 so that you can tell how much you've moved it out, and then how much to turn it back in, and take in 10 thou cuts or 15 thou cuts at a time. Okay, I think that sort of covered that quite extensively. So thanks for watching. Bye for now. And for all the beginners out there watching, cutting threads, it's even more difficult to cut internal threads when you can't see, you don't have clear vision. You're going to have to be a lot more careful. But practice makes perfect. Thanks for watching. Bye for now.